Chapter 3, Section 5 is operations of matrices. So we're going to be multiplying matrices by a scalar factor of k. So what does that mean? You know how you guys usually multiply a number? Let's say it's a k, you distribute that k and it'll be 2k plus xk. You're going to be doing the same thing but with matrices. So what does that mean? That k is going to be distributed into the A, to the B, into the C, and into a D. And you're going to get it's called, you're going to get a scalar of the original matrices. Now matrices are just brackets. You can have rows of 2, columns of 2, 3, 4, 5, where they just have numbers. So in this example, we have a matrix of 4, 1, 7, negative 2. And then we have a negative 2, which is a scalar factor, which you're just going to multiply to get this. So we get, this is the written out version, which is negative 3 times 4, negative 3 times 1, negative 3 times 7, and negative 3 times negative 2. The final answer is going to be negative 3 times 4 is negative 12. Negative 3 times 1 is negative 3. Negative 3 times negative 7 is negative 21. And negative 3 times negative 2 is positive 6. So your answer would be this matrix right here. The final full solved out answer. For example 3, we multiply a matrix by a scalar factor. Now the scalar factor is 5. So it's going to be 5 times negative 12, 8, 6, negative 16, 4, and 19. Now, notice how it's 5R. R is just the name of the matrix. Because they do get long, we just name them with a letter. In this case, R equals the matrix, or R is the matrix. So we're going to do, I'm going to write out all the steps. It's going to be negative 12 times 5, 8 times 5, 6 times 5, negative 16 times 5, 4 times 5, 19 times 5. And then you actually get to solve it, and that's when you get your final answer. 12 times 5 is negative 60. 8 times 5 is 40. 6 times 5 is 30. Negative 16 times 5 is negative 80. This one's 20. And then 19 times 5 is 95. So your matrix final answer is this one. Yeah, you would put 5R equals, and then you keep going. Just as a general rule of thumb, a lot of these problems get really long. So if you have a paper, I just kind of drew it there, and you're writing matrices, kind of keep a pattern. What I used to do when I was in your shoes was I used to do this. I would put arrows up to where I was going. Because as you guys get more into them, you guys, they get very long. So I would put arrows to what it was my next matrix. Just make sure you guys can follow the order. And you have a pattern that you guys understand. The arrows help a lot. They help me when it comes to grading because I know what is your next step. And I know where you made the mistake or where you didn't make a mistake. For right now, it's just going to be 2 or 3, so it's really not going to be that bad. But as we get further into the lessons, they do get longer. All right, so to solve this, negative 4 times c is going to be negative 4 times 8, 0, 3, negative 2. Negative 1, negative 4, negative 2, 9. So let's put them into the matrix. So it's going to be 8 times negative 4, 0 times negative 4, 3 times negative 4, negative 2 times negative 4, negative 1 times negative 4, negative 4 times negative 4, negative 2 times negative 4, and 9 times negative 4. Now, my final answer is going to be negative 32, 0, negative 12, 8, 4, 16, 8, and 36. Negative 36. So the properties of matrix operations. For any matrices A, B, and C, you can have 1, 2, 3, 4, 5 matrices for which the matrix sums and products are defined, and any scalar k, the following properties are true. You have the cumulative property, which means that if you add A plus B, you would be the same thing as adding B plus A. You can do, let's say, 2 plus 5. It's the same thing as saying 5 plus 2, because they're both going to give you 7. If you have A plus B associative property plus C, and then A plus BC, you will get the same thing. What does it mean by associative property? Let's say if you have 2 plus 5 plus 3 equals 2 plus 5 plus 3, you'll get the same thing. This is 7 plus 3. This is 2 plus 7. Wait. Sorry, it's supposed to be 8. 2 plus 8. You end up with 10 on both sides. So that's why it's the associative property. It works both ways. That is the associative property. Now we have the left scalar distributive property, which is what we did before, but we distribute from the front into the parentheses. But we also have the right scalar distributive property. That is when we distribute from the back side or the right side of the parentheses. But it gives you the same thing, which would be the distributed number. So I'm going to go over how to add and subtract matrices. It's fairly simple. I'll show you though. So we have, I'm going to make up a matrix right now. Okay, so how do we add matrices? We add them by the placement. So we would add the 8 and the 9, the 5 and the 3, the 2 and the 1, and the 3 and the 2. So we do them, I'm going to do it by color. So we would do the 8 plus the 9, that is 17. The 5 plus the 5, that is 10. The 2 and the 1, that is 3. And the 3 and the 2, that would be the 5. Now, how do we subtract matrices? I want to make a new example. Or I'm going to use the same example, actually. Okay, so it is the exact same way. We take them one number at a time. You take it one number at a time. So how do we do it? We're going to do 5 minus 9. 8 minus 9. 5 minus 5. 2 minus 1. And 3 minus 2. Now, why am I writing it down here and I didn't write it down in the other one? I am writing it down here because I want you to notice that this negative, you have to apply it to all of them. So it's just a way for you guys not to forget it. Your final answer would now be negative 1, 0, 1, and 1. So this will be the final answer for subtracting. This will be the final answer for adding. So for the last example in the notes, we have if matrix A and matrix B are that. They want us to find negative 4B minus 3A. So let's separate this. Let's figure out what negative 4B is going to be. So negative 4 times negative 4, negative 8, 2, negative 3. That's going to become negative 4 times negative 4, negative 8 times negative 4, 2 times negative 4, negative 3 times negative 4. That's going to be 16, 32, negative 8, and 12. Awesome, we found the first section, which was 4B. Now, let's figure out what 3A is. Now, the reason I am doing positive 3A and not negative is because you can do either way. But what I'm going to do is I'm going to do 16, 32, negative 8, 12, minus whatever this matrix is that we're going to solve for. But if you do minus or times negative 3a, if you do the negative here, this has to become positive. So just make sure you understand that if you do a negative 3, it's going to be adding the matrices. If you do just positive 3, it's going to be subtracting. I'm going to do positive 3 for now to deal with the negative later. So it's going to be negative 9 times 3, 12 times 3, 2 times 3, negative 6 times 3. That's going to be negative 27. 12 times 3 is 36. 6. And negative 18. So I'm going to write it in here. Now here we have the negative 4b. This first one, we have 3a. Awesome. Now let's subtract it. It's going to be negative 4b first, so that's what I wrote down, minus 3a, which is what I wrote down. So let's figure out how it's going to be. It's going to be 16 minus negative 27, 32 minus 36, negative 8 minus 6, and 12 minus negative 18. So my final matrix is going to be, remember 16 minus negative 27 will become a positive, so it's going to be 16 plus 27, which is going to give me 43. Then 32 minus 36 is going to give me negative 4. Then we have negative 8 minus 6 is going to give me negative 14. And then we have 12. Remember, minus negative 18 is going to become a positive, so it's going to become 30. So that will be your final answer.